In this video, we'll provide a quick lesson on using the full text indexing and search capabilities in SQL Server 2005 Express Edition. With full text search, you can quickly search through large amounts of character-based data fields. You can also search through entire documents like Word documents or other Office documents, HTML, XML, or even ASP.NET documents that are stored in your database tables. Now, sure, you could use the like predicate of the where clause to search through text data, but it's not really optimized to search through large amounts of data in each field. So this is a special scenario that required a special type of solution, and the right tool for that job is full text search. Additionally, full text search allows you to produce queries that rank the results differently based on a number of different criteria. For example, the weights that you define to each part of the search, or possibly to the proximity to other keywords in your search, or even to inflectional forms of specific words. And to that end, we're going to look at how to search for the term foot, but also get search results that have other forms of the word, like feet, for example. Also, you can tweak how the indexing is performed. You can tweak the thesaurus. You can filter out noise terms like the word the and the word and so on, and quite a bit more. Now, unfortunately, I can't demonstrate all of this. In this lesson, I'll simply get you started with how to set up full text searching, how to create catalogs and indexes, and several different types of searches to get you started. If this is something that you'll be implementing in your own applications, you'll definitely want to consult the SQL Server 2005 books online, starting with the article that's titled Full Text Search or Full Text Search Concepts. At any rate, you're going to need to start out by installing SQL Server 2005 Express Edition with Advanced Services. First of all, let's go to the Express Edition website. You'll go to SQL Server Express Download. You'll scroll down to the actual download page. And under number 3, you'll see that on the right-hand side there is the ability to download SQL Server 2005 Express Edition with Advanced Services SP1, so you'll want to download that. Additionally, you may want to download the AdventureWorks samples, so by clicking on the download link in section number 4, and near the bottom of that you can see where you can download the AdventureWorks DB.MSI. I've already taken the liberty of downloading both of these, and so let's just quickly walk through the steps of installing SQL Server Advanced Services, and I'll show you what we'll need to do in order to get this to work correctly. And so one of the things that I'm going to do is create a new instance on my existing machine of SQL Server 2005 Express Edition with Advanced Services, and we'll use that for the examples and just to demonstrate how to set up full text indexing and searching. And we'll go through the normal steps that you'll usually take in order to install SQL Server. It runs its configuration check. We'll want to unhide advanced configuration options. Under feature selection, we'll want to go to the database services and select full text search will be installed on the local hard drive, and we'll select next. And we'll call this new instance full text search and select the next button. And we'll select the default options for the next couple of screens here. We'll get to this screen that will allow us to select whether or not we want to install user instances. If you're not sure what user instances are, I would refer you to lesson number 7 in this video series. But what's important here is that full text search is incompatible with user instances. When you install SQL Express with Advanced Services, you're going to need to make sure that to deselect the Enable User Instances checkbox in order to turn off or disable user instances. Now, if you forget to do that, or if you want to use full-text search on an existing database, then you're going to need to turn user instances off manually, and you can do that with the following T-SQL statement. You'll open up a new query window, make sure that you're attached to the AdventureWorks database or whatever database that you're currently working on, and run the ASP configure and user instances enabled, and set that value equal to 0. Now the remainder of the options we can just select the defaults, and I'm going to pause the recording as it continues to install. After completing the installation, you may want to set up the AdventureWorks database, the sample database that I'll use for the next few minutes. There are plenty of columns in the AdventureWorks database tables that we can create indexes on and experiment with. To install, just merely double-click the MSI and walk through the installation steps. I've already gone through the steps of installing the AdventureWorks database, and so I'm going to shut down my folder, and then I'm going to launch SQL Server Management Studio Express. I'm going to connect to my new instance. And I'm going to attach to the AdventureWorks database using the steps that we've seen in previous lessons. Databases in SQL Server are full text enabled by default unless they're created by using SQL Server Management Studio Express. To enable a database for full text search when you create a database by using Management Studio, you'll go to Databases to create a new database, and you'll want to select this Use Full Text Indexing option, and then you can continue creating your database with the other options as well. I'm going to cancel for now. Now, if you want to enable an existing database for full text search, you'll right-click the database, select Properties, you'll go to the Files page on the left-hand side, and then make sure that Use Full Text Indexing is turned on, as it is in this case. Next, we're going to want to set up full text indexing on a table in our database. In SQL Server 2005, this is a two-step process. First of all, we'll create a full text catalog in order to store the full text indexes, and then we'll create full text indexes. So at a high level, you have this hierarchy. You have a database, and a database can contain 0 or more full text catalogs, and each full text catalog can contain 1 or more full text indexes. Now in our simple scenario, we're only going to create one full text catalog, and each time we create a full text index, it'll be put within that full text catalog. And hopefully this distinction will become clearer once we press through some of the examples. Now if you're using SQL Server 2005 Management Studio Express, unfortunately some of the wizards that help you through the process have not been included. So you need to license and install a different version of SQL Server 2005 in order to gain access to some of those tools. However, you can still use full text search. We'll just have to write some of the code by hand, and honestly it's not all that complicated once you understand some of the basics. So first of all, let's create a full text catalog. I'm going to open up a new query window, and I'm going to paste some transact SQL, create full text catalog, and then the name of the catalog. In this case, I'm just going to call it something simple like my full text catalog, and I'll execute this. And after a few seconds, we get the completed successfully message. So what did this do? Well, this statement creates the full text catalog in the default directory specified during our setup. There's a folder now named My Full Text Catalog, and it's in the default directory for our instance of SQL Server. The catalog is where all the index files, as well as the configuration files, will be stored on our hard drive. SQL Server Full Text Search creates indexes, which are simply special files that keep account for each word in each document or each column, and associate each word back to the record in the database where that word was found. So, as you can imagine, these files can grow quite large. So let's open up our Windows Explorer and navigate to the directory where our catalog was created. You can see in the FT data we now have full text catalog, and these files that are managed underneath this folder are indexes and the sources and all types of information that full text search needs in order to run. From a conceptual perspective, if you'd like to have some more information on the structure of an index, go to this document out on the MSDN help, or find this article within SQL Server Books Online. You can see that it has a nice walkthrough using some example documents how the index would be created for those example documents, with some explanation as well. And so now that we're on the topic of indexes, now that we've created that full text catalog, the next step is to create a full text index. Before you can create a full text index, you have to determine whether the table already has a unique single column non-nullable index. The full text engine for SQL Server, which is called the MSF-TE SQL service, uses this unique index to map each row in the table to a unique compressible key. Now, if you already have such an index, you don't have to create another one. If you don't already have an index, then you're going to have to create one, and so here's an example of how to do it for one particular table. Create unique index, and I called it UI for unique index underscore product review, on the table name, which was production dot product review, and then I'm going to pass in the columns that will create the index on. So now that you have a unique key, you can create a full text index on the product review table. A full text index stores information about significant words and their location within a given document. This information is used to quickly compute full text queries that search for rows with a particular word or combination of words. You can create a full text index on one or more columns of a table in a database. Only one full text index is allowed per table. So first of all, let's take a look at the simplified form of this full text index creation. Notice that we have the term create full text index on. This is the table name. This is the column that we're going to want to index. This is the unique index that we created in the previous step. This is the name of the catalog that we created earlier, and where we want the files, the indexes, to be stored on our local hard drive. And then finally we have this with change tracking auto, and that will require a little bit of explanation. The process of creating and maintaining a full text index is called index population. This final clause in our statement here specifies how you plan on initially creating and then maintaining your full text index. And there are three different types of modes of population. First of all, there's full population, and that typically occurs whenever the full text catalog or the full text index is first populated. The indexes can be maintained using change tracking or incremental populations. And unless you tell it not to, this happens automatically whenever you create the index. The second mode of population is change tracking, and so after the initial population is complete, then SQL Server can track the changes that are made to your data and then propagate those changes to your full text index. Since we have auto turned on in this statement with, as you can see, with change tracking auto, then SQL Server will just handle this for us automatically. And then finally, there's another mode of population that is incremental timestamp based, and this allows you to manually kick off an update to only those rows that have changed since the last population update, as specified in a special date time field that you also have to supply. The reason you get this granularity of control is because maintaining the full text index can be a very processor and file I/O intensive operation. In fact, for this very reason, some organizations, some database administrators may ban this completely. Also, some web hosting companies may not allow you to do this. But assuming that you did want to use this, you do have a level of control, and for example, you might want to schedule it to perform only at certain times in the day. You get to specify how you plan on maintaining that index at the time when you create it. So if you wanted to use anything else besides auto, you'd basically need to execute an alter statement on the index so that it's updated with the new values from the columns specified in the index. So please refer to SQL Server's books online for more details about the different index population modes. Alright, because we're going to use this later, I'm going to go ahead and execute this right now. And what I want to do is look at a second example of creating a full text index, a slightly more complicated one. So I'm going to paste in actually two statements here. Let me go ahead and just make a spacer here. Alright, and the first statement is going to create a unique index for us on the production.document table, and we'll want to create that unique index on the document ID column. And after we do that, we're going to then create a full text index on production.document. You'll see here that we specify the column name just like we did in the previous example, but there's also two additional arguments that we're passing in. The first argument, called type column, has the column name file extension. So let's do this. Let's take a look at our production.document table in the AdventureWorks database. Get a clue about what is actually going on here. Here's the production.document table, and here you can see we have our document ID that we created a unique index on. We have a file name, a file extension, and then also the document, which is stored in a var binary max. So let's do this just for fun. Let's go ahead and open table. We can view the values that are in this table. And so here we can see the title of the document, the file name where it's stored on our file system, the file extension. You can see that this is .doc. So these are Word documents that are being stored in the document column of our database. So we're actually storing Word documents here and indexing them with full text search. And so this file extension column becomes important. Basically, we're stating here that we want the full text search engine to index a binary field that contains a .doc file, a Word document. Full text search must know which column in our database will contain the file extension for the file that's saved in the document column. So it uses that file extension to load in the appropriate filter for that document type. In this case, it's going to load a filter for Word documents, and you might be wondering, well, what are all the types of documents that you can store within a var binary and expect them to be indexed by full text searching and indexing? Well, let's do this. Let's run a quick little query here. Just paste it in, and that information is stored in a system table called full text document types. So let's just execute this, and we'll see that we can index ASPX pages as well as ASCX, so controls that we create for our ASP.NET pages, batch files, command files, C++ source files. Here's our doc and dot for templates, HTML files, INI files, and there's just quite a few, even M3U, so playlists, PowerPoint and PowerPoint templates, URLs, VBScript, XML, and I'm sure there are ways to extend this so that you can create other filters for your own custom file extensions. So at any rate, that's what this line does. The next little option here is language 0x0, and this defines that the language that should be used when parsing the full text column is, as we can see off to the right hand side here, for a neutral language. So OXO is the locale identifier for the neutral language, but you can specify a given language. For example, if you know you'll be storing documents that are written in French, you can specify French here, as opposed to just selecting whatever the default locale is within your installation of SQL Server. So based on the language, a different set of files are referenced for dictionaries of words that are used to parse through the text. Things like word breakers, stemmers, noise words, thesaurus, and so on. And I'm not going to explain these in any depth, but SQL Server Books Online has information about these kinds of dictionaries, and these settings are used to parse through the words in the document that you're storing in the database in order to create an index. So it has to know which dictionary to use. Should it use the English, the French, the German, and so on? And once it knows that information, then it can choose the dictionary that's appropriate for that language, and using that dictionary or those dictionaries of information, it can figure out what terms are nouns, which ones are verbs, which ones can just be ignored while you're doing your indexing. So in this case, as I said just a moment ago, you can see that it's set to 0x0, and that is a hexadecimal value that for the neutral language locale identifier. So in other words, in this case, we're asking it to look at the localization settings for our instance of SQL Server, which by default is English. Now there's actually quite a few more indexing options. Once again, if you're planning on using this for your own purposes, then you're definitely going to want to research this more, and you can learn more about creating the full text index at the following URL that I'm going to just paste in here, and the article is called Create Full Text Index. So you might want to pause and jot that down. Okay, so let's go ahead and execute this. Let's make some room for ourselves here. We're going to create the unique index, then create the full text index, and it seems to have worked correctly. Okay. Okay, so once the index is built, statistics are collected for use in ranking, and now you can start writing queries to collect information from your index. So let's do this. First of all, let's start with a very simple select query that uses a special predicate called contains in the where clause. Let's go down here, and I'll just select that and select execute. And again, this is probably the simplest type of full text query that you can possibly create. There's quite a few other qualifiers that you can stick in here too, and we'll talk about those in just a moment. But fundamentally, we have where we're selecting the comments column from our product review table that we've already created a full text index on, and we're going to search for the term learning curve. Now, we might want to switch over here to results to text so that we can see the results a little bit better. So I'll execute this again, and you can see here if we look through the text, we'll find learning curve. Now, as I said a moment ago, there's actually quite a few options for the contains predicate, and so I'm going to refer you yet to another resource on SQL Server Books Online or MSDN. Here you can find the full reference for the contains statement, and it's actually quite a few pages long if you were to try to print this out. But in a nutshell, the contains predicate can search for a word or phrase, the prefix of a word or phrase, a word that's near another word, a word that's inflectionally generated from another word. For example, the word drive is the inflectional stem of drives, drove, driving, and driven. You can also search for a word that's a synonym of another word using a thesaurus. For example, the word metal can have synonyms such as aluminum and steel. And so once you begin to tack on some of the additional options of the contains predicate, you can develop quite a powerful inquiry into your text. So there are two basic parts to the contain statement. You can see here that first of all we have a column, or you can actually include a list of columns that you're going to be searching against. And those columns have to be included in the index that you actually created for your given table. Okay. And most of the time, as I've done here, you'll probably only specify just one column, but it's entirely possible to search against a long list of columns. So then the second part of the contain statement is the actual search condition. You'll notice that I have two sets of quotes. I have a double set of quote that surrounds two words, which means I want to treat these essentially as one word together, and also then a set of single quotes which just defines the entire contains search condition. So let's go to a slide real quick and take a look at the different kinds of things that you can do within this contains search condition. First of all, you can use a wildcard. So in this particular case, we're looking for the term compustar, and it would bring back computer, computers, computation, and compulsory. You can use and, or not, and also the binary representations of those, the ampersands, the pipe symbols, and so on. And you can see that there's really two different forms, these last two examples, where we're using and to search for those terms anywhere in the document, as opposed to a complete phrase, computer software install, in that final example there. You can also use the word near, so we're looking for and ranking higher those results, those documents that contain the word computer closer to the word software. So in this case, we're beginning to refine our search results, not just to bring back any documents that have both the word computer and software, but to rank higher those documents that where those two words are even closer together. Okay. The next little example we'll take a look at are the forms of, which allows us to search for inflectional forms of, for example, the word happy, which would match the word happy, happier, happiest, and happily, and so on. And then finally, we'll take a look at this rather complex example of the is about phrase, and that allows us to specify the weighted term keyword. So in this particular case, we want to give different weight to the different terms in our search. So if the word development shows up several times, it would outweigh a search result that had perhaps the words computer and software several times as well, just because of the weight that's been associated with the word development in this example. And I could go on and on and on. There's a lot of other options here. I just wanted to point out a few quick examples of the ones that I saw immediate value in. Okay, so in the last couple of minutes here, I just want to see a couple of these types of queries in action and see what they'll bring back for us and give you something to experiment with. So the first example that I'm going to show you, let's go ahead and paste it in here. So in this first example, I'm going to show a couple of things. Besides the creation of the unique index and the full text index, which we'll do right here, I'm just going to show this simple select statement that uses contains. And there's two interesting things about this. First of all, I have a where clause that contains other predicates, which we haven't really seen up to this point. So here I'm filtering out the product description ID of 5 from my results. So where product description ID is greater or less than 5. And then also in my contain statement, I'm using the and. So I'm looking for the inclusion of the word aluminum and spindle within my results. So let's go ahead and execute that. And you can see it brings back description aluminum alloy cups, large diameter spindle. So even though these are, again, not right next to each other, using the and we can search for them within the same document. Alright, this next example is quite a bit more complicated. Let's go and paste this one in. First of all, it's going to create a unique index on the person.address table and create a full text index as well on the address 1 column. And now in the SQL statement itself, I want to point out there are two things about this query that are interesting. First of all, notice that we're going to use the isAbout phrase in order to weight different items within the search results differently. Let's do something real quick before we get too far. Let's go to the person.address table. Take a look at the columns. So our address line 1, which is what we'll be using here, is of type nvarchar60. Okay. Let's go ahead and execute the statement. And we will use that to kind of take a look at the different rankings. So the isAbout, if you recall from a few moments ago, will allow us to give different weight to different values. In this case, we're modifying using bay and the wildcard symbol to say if it's bay and street, then give that the highest weight. If it's bay and then followed with the word view, then give it some weight, but a little bit less than if it were followed by street. And then all the other ones can be just, given equal weight. So we have this first one, bay street, with a high rank value. We'll get back to what this is in just a moment. And then bay view has a lesser rank. And then finally we have Bader Court, Bayberry, Bayshore, and they have less rank. Okay, so the first part about this is using the isAbout statement. The second part is where do we get this rank value? Well, notice that we're not using contains, but we're using a variation on it called contains table. And it basically creates a temporary table that contains the table's key column and a column called rank. And the rank column is a value from 0 through 1000 for each row that indicates how well a row matched the selection criteria. So in this particular case, we are doing an inner join with this temporary table called key table, and we're going to set where the address.addressID, so the primary key, equals this temporary table called key table that we're defining right here, and we're going to set that equal to the key of that table so that we can join those two together. And the reason for joining is so that we can display both the address line 1 and the ranking within our results. Then we're going to use that ranking to order by that column in a descending fashion. Okay, so that was a pretty complex query. Let's go on to one that's slightly less advanced. Here we're going to use that forms of keyword in order to get inflectional forms of foot. So let's execute that one. And let's see some of the results that are being brought back here and see if we can find forms of foot. Okay, so I can find the word foot here. Let's see if we have... Here's another one, feet. Okay, so the inflectional forms again will give us not only those results that contain our search criteria, but also any forms of that word as well. Okay, and finally for the grand finale, I'm going to paste in another pretty actually convoluted long bit of code here. And what we're going to attempt to do in this is to update a full text index by inserting a new row into the database, specifically into the product review table. And if we set up the full text index correctly on that table, and we set it up with the change tracking set to auto as we discussed earlier, then whenever we get down later in the query, we're going to first of all wait for 30 seconds. That should give the index plenty of time to index this new row of data. And then we're going to try to find it within our database by crafting a SQL statement that is specifically geared at grabbing out those elements that we would expect to see in our table. So let's go ahead and select all this and then select the execute button. And we're going to have to wait for about 30 seconds, so I'm going to pause the recording. And after 30 seconds you can see that we did get the row returned to us within our select statement here that looked for in the comments where we have the words AdventureWorks and Redmond and Tabor, and so we were able to successfully execute a full text index query on a new row of data that was indexed correctly, and we gave it some time to execute it. So very cool. Now if you don't get the results that you're expecting, you want to make sure that you've followed the steps correctly in setting up your full text indexes, also making sure that full text index searching is turned on for your database and that user instances are turned off. You would obviously want to consult and do some testing with taking a look at your event viewer and looking in the application section to see if there's any information there, any warnings or errors that may have occurred. You also want to make sure to check, and let's go ahead to administrative tools here and check the services, and the service that is being used for full text index searching is the SQL Server full text search. Let's take a look at the properties. The name of it is the msft.esql.exe. You might want to make sure that it is using the correct account to log into your instance of SQL Server. And finally, in the realm of debugging, let's do this. Let's go ahead and close down that, and let's open up Windows Explorer, and we're going to take a look at where we can find the logs for full text index. So program files, let's go to SQL Server. I'm going to look at my particular instance of SQL Server. Go to the MS SQL folder, to the log folder, and you'll see here SQLFT with the numbers to the right of it, .log. And you can open this up into Notepad and view all the messages from full text auto population from the indexes that you created for your table. And let me conclude by saying that this was not intended to be a comprehensive look at full text indexing and full text searching. There's quite a bit more, but hopefully this will get you started off into the right direction. I hope you enjoyed this video. If you did, please visit learnvisualstudio.net, where you can download over 500 ScreenCam videos on all topics related to .net, C#, Visual Basic, ASP.NET, even SQL Server, and a lot more. Thanks. Have a great day.